Good morning, who is online? Simulandile? Simulandile? Can you hear me? Good morning. Thank you. You will be my springboard. Hopefully, can you see the screen I'm sharing? Thank you. Let me just check what these guys on YouTube will be seeing, and then I'll go with you. Great. Yeah, YouTube also gonna see there. I'm gonna put a bit high to them. Good. Are you from PHYV or FVV? FVV. Therefore, you also take this, what is that? I will be starting with the PHYV question. Today's session is on the wave, sound and the wave. You alright with that? Yeah, good. Then I'll be pushing you now. Everybody, hopefully the screen's alright. You said the YouTube also. I hope there is nothing muted. They must be able to listen to our conversation. Yeah, for question number, as I said, I'll be starting from this question number 9 on PHYV. Basically, oh, come on, this thing doesn't yet come. Oh. Maybe let me just you see this guy looks freezed. I'm gonna close, reopen. Just hold on me. This my tablet is kind of freezed. I hope now she is active. Then move, man. I know. It's here. Discard. Now display. Yes, she is working now. Thank you. Therefore, I said we will be starting from question number 9. The remaining questions, if I have to go back, this is from here. James must have gone through this question number 1 to 8, even including 9 yesterday. These ones are on sound, I believe. Yeah, it's a sound wave. 1, 2, 3, 4, 5, 6, 7, 8, 9. He in principle must have started question number 9 also. I supposed to start from 10, but I just read it through that the question number 10 actually depend on question number 9. That's why I will be starting from question number 9. If you have any question from 1 to 9, please don't hesitate to ask me. Otherwise, obviously, you will also find it on the YouTube. James must have gone through question 1 to 9. Please, therefore, I'll be starting from question number 9. On question number 9, I'm going to bring my tablet in. Yes, we will be looking for basically Doppler's effect. If I read through, I just had a chance to read through this morning. It says a track is moving. We have got a speed of the track. It's moving at 36 meters per second. Passes a police car. It's not yet. Actually, it's not passing. That statement is not good. It's actually approaching. Better, I will say approaching a police car that is moving. This pass is confusing. It's not passing yet. It's actually approaching a police car, which was moving at 45 meters per second in opposite direction. If you think of it, if I say the truck is moving this way, that will be my truck. Kind of, I'm trying to plot. That's my truck, and then she's moving that way, and the police car is coming from opposite. Let me say this is my police car. My drawing is such bad, you could see. This is my police car, and then it's coming that way. They are not yet passing each other. They are approaching. The speed is given. The truck is 36 meters per second. The police car is 45 meters per second in opposite direction. It says the police car actually releases a kind of a sound, which is a siren. As I said, if the frequency of the siren relative to the police car is 500 Hertz, What it means is that this thing actually is releasing a sound wave which is moving in this direction, where the frequency F0 is given as 500. That's what it says, 500 hertz. And then it asks us that what is the frequency heard by the observer in the track as the police car approaches the track. You see, the speed of sound is given as 343 meters per second. If it is me, what I will do is basically I'm gonna go back to what I have. I have got kind of a drawing. I wish, do I have? Let me go back one step back. You see, this card. I'm gonna start presenting. I want to start it here. Now, if you see, this is what I just copy paste from internet. Actually, it says the question is, it's a relative speed per se. It's a Doppler effect. If you are in a truck and then a police car is coming from opposite side, and then the police releases a sound which is a frequency of 500 hertz. That sound is a siren. The sound of that noisy wee, and then it's the frequency is given. As you approach toward this sound, what is the frequency that you hear? That's the question. What is the frequency heard by the observer in the track as the police car approaches the track? Therefore, as this drawing is better, now I'm having then this frequency is, or the sound of V of the sound is coming toward the track. Its frequency is F0 is 500. This is what the question is looking for. If you read through once again, it is to do with Doppler's effect. What the Doppler effect says that if two objects are approaching each other, whereby the first one produces a sound, the second one receives the sound, that's FL is the listener actually from this equation. L is the listener. This is the person in the track. That means this the listener is here. L-I-S listener. Oh, spelling L-I-S-T-E-N-E-R. And then this is source. Then we know that the frequency heard by the listener is given by the frequency or the sound of the sound, the speed of the sound, which is V. Now that V is given, this one, this is V, velocity of a sound in air, and then the speed with which the listener is running toward, this is VL, divided by V plus or minus Vs. Please check that one. Therefore, I could write this speed as that frequency F0 or F of the listener would be equals to the F of the source, Fs, which is we have this one 500 into, now V is V, it's a V speed of sound which is given, this is V, plus or minus, that is what you should be careful. Then it's given in this table. In the table, as you could see that if the source is moving toward the listener, the source is moving toward the listener, this is where I'll be looking at, Vs is negative. The bottom one is negative if they are moving toward each other. If the source is moving away, it's not our case now, we don't have away, they are both approaching, we don't have that Vs positive. If the listener is moving toward, again we have this case, the listener is also moving toward to the source, VL is positive. Therefore, you could easily see that it's plus VL divided by V minus Vs. This is basically what the question is looking for. If I repeat, this is to do with the Doppler's effect. The Doppler's effect in terms of frequency is given by Fs, is the source frequency, plus into the bracket V speed of sound V plus or minus the speed of the listener away or toward, divided by V minus or plus. You could see on this equation is not nice actually. It says plus minus. It's rather plus minus. I could write like this. It's actually Fs into V plus or minus VL divided by V minus or plus. It's opposite of Vs. That's what I would like to have. If the listener is moving toward, it's going to be plus. If a listener is moving away, it is minus. At the same time, if the source is moving toward, that is minus. If it is moving away, it is plus. Therefore, it's the opposite case. In our case, though, this is a frequency easy. Therefore, this one is a 500 into 343 plus, come on, plus, what do we have? The VL is that is moving at 36 divided by 343 minus 45. Hopefully you pick it up. Then if you go through this mathematics, easy, I just did it with the calculator. I got a value of 635.9, 635.901. I'm just reading from my 06 rather, is hertz. If I approximate to whatever multiple choice is given, I could say 636 hertz. Are you happy with this one? Mandile? Spin up, finger up or finger down. Are you happy up to now? Hopefully you should be. Okay, then this means the answer must be B, obviously, 636. I'm just gonna go into this one, 636, that's what I get, 636. To check, hopefully, she will say yes, it is correct. Yeah, correct. Number 10, where I'm supposed to be starting, I could read from here also. Number 10 says, it's a track moving at 36 meters per second. It's the same question, that's why I'll go back to 36 actually. Passes a police car moving at 45 meters per second in opposite direction. If the frequency of the siren is this one relative to the police car, again the same question, what is the change in frequency? This is what we are looking for. Change in frequency heard by the observer in the track when the two vehicles pass each other. You see? Now, meaning we're looking for change in frequency. In the case of 36, they are approaching each other. We knew. In the case of question number 10 now, they must pass each other. Once they pass each other, there will be a frequency change. You know, if you're listening in the car in this scenario, what you simply hear is, when the police car is coming to you, the frequency increases. That's what we get now. Of course, you will hear that it go, and then it slows down as you move away. That's why we see from 500 hertz, we get now 336. Because it's approaching, the frequency increases. When it passes, now the frequency decreases. We have to calculate that the frequency decrease. What it means is now, okay, can I pass next slide? Yes. What I have is, when they pass each other in this situation, okay, that is what I'm having now. They passed, the track is moving that way. The police car now moved this way. They passed. Therefore, I would be expecting the frequency will be less. Basically, the approaching one, we know this thing is plus and that is minus. Then the moving apart will give me the top one is minus, the bottom one is plus. If we work through this one, now the next frequency, if I call this one F2, when they pass each other, after they pass each other, would be equals to, again, 500 into 343 minus now the calorie, which is 36, divided by 343 plus 45, using this expression because the frequency changes now. If you calculate this one, I got it again with the calculator, 395.61 hertz. This is a frequency when they pass up each other and then you're going away. That means the frequency goes from and then it slows down. You could see now it is low. It is below 500. The delta frequency, delta F should be, therefore F1, which we get up to 1, minus F2, which we just get. I'm going to put it in absolute value. In the case of F1, remember, we which is equal to 650, what is it, 35 or 36, minus, this is what we approximate, and then this one, let me approximate 395 or 395.6 according to this equation. Oh, okay, if you just find out that this delta frequency is actually about 240, about that 240 hertz. Therefore, when it's approaching, the frequency is higher. When it's going away, the frequency is low. The change in frequency between these two scenarios, that's what we're looking for, change in frequency, is 240. Oh, I forgot to check my group on the YouTube, YouTube. Thank you those of you who tuned onto YouTube. I'm just pop back and watch, and there are a couple of you listening, you watching on the YouTube. Thank you for joining me this morning. Please, if you have question, because you cannot connect directly to me, means you don't have I don't have a video or audio, rather I don't have an audio connection to the YouTube. If you have question, please drop your message where I say, I'm gonna say again, hi. You see, that is what my chat. You could chat below that one, then I will pick up your question. Thank you for coming on the YouTube as well. On the Teams, please, if you have also a question, you could simply switch on your mic and ask me a question. Thank you. Let's continue then. Hopefully question number 9, question number 10 must be easy by now. Okay, let me check question number 10. Therefore the answer is 240. That's what I get. Let's check. Should be correct, obviously. Yes, it's correct. Therefore, question number 9, B. Question number 10, C. This is what I'm getting. Happy? I'm holding on. Those of you on YouTube especially, if you have a question, please populate your question on the chat. Therefore, I could pick your question soon. I've gone through question number 9 and the question number 10. Basically, question number 9, number 10 is on Doppler effect. I'm gonna go back to my this one. Where am I? Yeah. Come back. Basically, we discussed about Doppler's effect. I could come out here. I don't want to see it. I'm waiting for the YouTubers in case somebody have got a question. Discard and then go back so that I don't need to clean this. Question number 9 is this case, and then I said use Doppler's effect. On the Doppler's effect, you could see easy. Somebody who has question on the Teams maybe? Okay, guys, those of you on the Teams, please, when you join, would you mind to mute yourself so that unless you have a question, please. Thank you. Okay, good. Question number 9, we've gone through. Question number 10, also we go through. If you have a question, please let me know here. Basically, question number 9 and the number 10 are based on Doppler's effect. In the Doppler's effect, the frequency listened by the listener is given by V plus or minus VL divided by V minus or plus Vs times the source frequency. If the source is moving toward the listener, Vs is negative, that's the bottom one. If the source is moving away from the listener, Vs is positive. The derivation, I'm hoping that you guys have done in class properly. The top one, listener move toward the source, VL is positive. Listener move away from the source, VL is negative. In this scenario, question number 36, this is the case. Because VL is positive, it is moving away from the source. Listener moving away from the source, a lie. Yeah? Is this thing all right? Listener, the track, moving toward the source. That's the plus, yes. Here, source moving towards the listener, negative. Therefore, this is correct. That equation is correct. Simply put it in, we got it B. And better do it here. In the case of here, I've got through this question. Now they're passing each other. What is the change in frequency? That is in question. Should I, well, a little bit on YouTube, people are coming in again and again. You can see now the number has increased. Guys, if you have got a question on number 9 and the number 10, please type on your chat saying that go back to question number 9 or go back to question number 10. I have done already. We have been online now for the last 20 minutes. I've done question number 9 and the 10. However, if you still want it to be done, please let me know. With that, let me not wait. For those of you who joined late, let you ask me a question, then I'll go back to you. Question number 11. I didn't do this one. We have got through. Maybe on Teams, are you happy? Okay, Sebastila, come in. Yeah? Oh, okay, let me go back to question number 9. That was what I was expecting. I'm expecting if you come in now, you will be struggling with. Let me start from, always goes back to question number 9. Then I'll bring you in. If you see on question number 9, this thing is confusing. Don't worry, I'm gonna come in. Just hold on. Come on, man. Don't worry, my tablet is crazy. You see on question number 9, if you read, the truck and then the policeman car is moving toward each other. Check there. A truck move at this meter per second. Even though it says passes, it's not true. This question is not right. It's approaching a police car. It's approaching a police car, moving at 45 meters per second. That means the police car is coming in this way on the drawing. The truck is moving that way. They are not yet past each other. Then it says if the frequency of the siren relative to the police car is 500, the frequency, this is what is 500, is equals to Fs. What is the frequency heard by observer? Meaning the observer is here in the truck. As the police car approach, you see, now it is approaching, meaning truck is there, police car is from the right, truck is from the left. They are coming toward each other. They are approaching. You happy there? I'm waiting for you, Subulele. Yes, good. Then because they are approaching, just go back to your equation. What is approaching? Meaning now let's go there. VL. VL, which is a listener, is positive. I'm pointing for you there, the positive, because listener is moving toward the source. Again, go back to now the source. The source is moving toward the listener. Again, we are here. In our case, therefore, Vs is negative, VL is positive. Therefore, you take that equation. VL equals to V plus VL, FL rather. FL is equals to V plus VL divided by V minus Vs. I said I work through this one, therefore, that the frequency we'll be looking for VL must be equals to 500 into 343 plus 36 divided by 343 minus 45. If you do this one, I got it about 395.61. No, 3, a lie, not 3. 635. Sorry, I copied the other one. The bad thing is I don't have eraser on this thing, man. You see, I don't have eraser now. I'm to go back to here. 500 into 343. Come on. My tablet is giving me hard time today. Yep. Yeah. Plus 36 divided by 343 minus 45. If you do this one, you get 635.91, which is about 636 hertz. That is what we're talking. We say B. Your question was, how do I know if it is, do I take a plus or minus? I said to you, just look through this one, read your case carefully. If it is negative or positive, in our case is this. Just the same question now. Come back. Yeah, the same question now. They already passed each other. When they passed each other, that means now the VLE becomes negative and then VS becomes positive. I'm just holding. Hopefully you're reading it through. In this case now, track is moving at this method, passes. This question is nice now. It passes. It has passed. Then the frequency of the siren is 500 hertz. It's given. Good. The change in frequency, we are looking for this change in frequency. Change in frequency is actually equal to F2 or minus F1. I'm going to take the absolute value. F1 was when they are approaching. We get it the 635.91. We already did on question number 10, question number 9 rather. Now F2 should be this scenario. This is F2, which is this case, which we should be getting as 500 into 343 minus 36 over 343 plus 45. This case, they passed each other already. And now this, according to my calculation, I got this one, 395.61. The delta F, therefore, the change in frequency is basically 395 minus 61.61 minus 635.91. I'm taking the absolute value. Therefore, I got about 240 hertz. And then just to answer your question, read thoroughly through. Are they approaching each other? If they're approaching, that is question number 9. Question number 10, they passed each other. Now they are going away from each other. If they are going away, meaning the listener is moving away from the source, VL become negative. VS is also moving away from the source. They are moving away from each other. Now VS plus becomes plus. Then the change in frequency is basically, or the new frequency that you get is using this one. The first frequency minus the second frequency, or the second frequency minus the first frequency. Make sure you are putting in absolute value. That is what you're looking for, question number 10. Are you happy now? Good. Great. Let's go then. Number 11. Maybe if my YouTubers came in by chance. YouTubers, as I said again, I can't hear. If you're speaking, I can't hear. I don't have any voice connection to the YouTube. If you have question, please type down. Happy. Question number 11. By what factor, it says now, you see this is to do with sound again. By what factor is the intensity of a sound at a rock concert louder than that of a whisper when the two intensity levels are 120 decibel and 20 decibel respectively. I believe there is a comma there, respectively. What it's given is for loudspeaker, The decibel is, let me say, loud speaker LS. Decibel, the sound level, this is intensity. I'm going to use comma. The intensity of loud speakers equals to 120 decibel. And then that of whisper, let me call it the intensity of WH whisper is equals to 20 decibel. That is what is given, but the question asks, what factor in the intensity? What is the intensity of the two? Okay, then if you remember, you could measure that this is an equation in the sound. I'm hoping that you have derived this equation thoroughly, or Professor Tim and Dr. Lindsay must have given you the sound beta. Bad thing, I don't have eraser here. Beta must be equals to 10 logarithm of the intensity I1 or I over I naught. This is a sound level in decibel. Okay, instead of I supposed to say beta rather. It is better if I write this one beta in that way instead of intensity. This is in decibel. Okay, the SI unit is in decibel. What we given is what is the intensity ratio. That is the intensity. What is I of the loudspeaker LS divided by the intensity of the. It's not my I was wrong there. Don't take I as what I say. It is B rather. I of the WH. That's what we're looking for. Then the best equation to use is this one. How do I use? Therefore, I will say beta of this guy, which is given 20 decibel must be 120 rather 120 decibel must be equals to, that's the B, not beta. B must be equals to 10 logarithm of I of the loudspeaker LB divided by I naught. This I naught is 10 raised to minus 10, but we're gonna erase this one. If you remove 10 on both sides, you could simply see that this implies that the 12 must be equals to logarithm of I of the loudspeaker divided by I naught. In the same way, for the whisper, 20 decibel must be equals to, I remove the decibel basically, 10 logarithm of I of the whisper divided by I naught. I naught is common. Again, you see this one, if you remove these two, 2 equals to logarithm of I of SP, this WH rather, WH over I naught. Now, this is the two equation you left with. Do I have a, I don't want to write again and again. Do I have, yeah, no, I don't have. I thought I've got a place to write. Difficult to handle, man. If I say therefore 12, well, what is the best way to do this thing? I'm going to take the difference of the two. 12 minus 2 would be equals to logarithm of an equation. If you call this one equation number 1 and then this one equation number 2, I'm going to say equation 1 minus equation 2 becomes, I don't have a space to write, must be equals to logarithm of IS, I of loudspeaker, I call it LS, divided by I naught minus logarithm of what is that? The I of WH speak. This is WH is for me the whisperer divided by I naught. Good. I think I know. It's good to use a minus. This means this implies what is 10, 12 minus 2 will be 10. 10 is equals to logarithm of A minus logarithm of B. You help me. Log A, common logarithm to the base 10, obviously. Logarithm log 10 minus logarithm of B, the whole base 10, should be equals to log of A over B to the base 10. Keep this one in mind. This is true. Then I will say logarithm of I of the whisperer, I of loudspeaker divided by I of the WH times, you see that I naught will disappear. I naught, how to disappear? LS divided by I naught times I naught over WH. I naught will cancel out to the logarithm of base 10. I'm going to hold here. If in case it's messy, huh? Why didn't I had? Just hold on. I'm going to go out and in because I don't have the eraser here. Yeah. Discard. I'm going to restart this question just to make it clean. What I say is the following. 12 minus 2 equals to logarithm of I of loudspeaker over I naught times I of the WH over, no, this is on I naught rather, this is going to be I naught over I of WH to the base 10. That is where I stop. This is good. This implies equals to logarithm of I loudspeaker divided by I of WH to the base 10. Then this is equals to 10. What I mean is this 12 minus 2 is 10. If you take around I of loudspeaker divided by I of S must be equals to 10 raised to 10. I believe that's the correct answer. What you might ask, can't I change my pen here, man? I can't change my pen. That's the bad side of it. YouTuber, are you still there? Oh, YouTube says there is an error in connection, but it will resolve soon. I'm gonna just hold on there. I don't like my PowerPoint here. But this answer is okay. The answer must be D. Meantime, just give me a minute, guys. I want to change this thing. I don't like this going in and out, in and out. I want to bring a PDF. It's easy to work with PDF than this one. Question, I'll be coming in. Yep, what is this? Yep, and tutorial 9. I'm on question number 11 already. Question number 11. Save. I'm bringing the PDF. Just hold on for me. File. Save as same place as a PDF. Hello. I am not. You're right, I'm not recording. Let me start. Don't worry, I will start recording. I'm also changing my, I don't like the PowerPoint. I could not erase it. I'll be with you soon. Just give me a minute. Go into tablet. Don't like this one. You see how many things I have to open to go through. Nope. I want to go to my tablet, no, my computer, go to the tablet and my document. I'm gonna paste it here. Bring it, please. Where is it? Okay. Just hold on. Good. Now I'm on a PDF. More of good. Then you said, am I not recording? You right, I'm not recording. Bad of me. But sorry guys, I was not recording. I will start recording now. Good. Thank you. Thank you for reminding. Back to it. Now it's a PDF. That's a great thing. Guys, I could see a couple of you just joined now on a Teams. We have worked through question number 9, question number 10, and the question number 11. Number 9 on a PHYV, question number 10, and question number 11. This is what we worked through. Just to just bring you in, those of you just joined me. Question number 9 says, this is what James has done yesterday. It is to do with Doppler's effect. This is the equation. But what you should do is, what is your scenario? You have got a source which produces a sound. In this case is a police car. And then you have got an observer, which is a listener in the track. In this question number 9, they are moving to each other. The police car and then the truck are moving in opposite direction. They are still approaching. Therefore, the source is approaching the listener. We take the negative, this one. Again, the listener is approaching this, moving towards the source. VL is positive. VL is positive. You take this one. Therefore, for question number 9, your frequency, let's call this one, F1 is given by this one. Using mathematics, we said this F1 is equals to 500 into 343 plus 36 divided by 343 minus 45. We get the answer is B. 2. I'm checking my stuff there. Good. 2. We said, okay, what about on this one? In this case, question number 10, they passed each other now. When they pass each other, we call it F2. See now how good it is. I could actually choose my pen to make it smaller. And then I could also have a, you see, this is what I was missing on Word, on PowerPoint. F2 is 500, and then the equation is now here because they are moving apart now. VL becomes negative, VS becomes positive, into 343 minus 36 divided by 343 plus 45. In this case, we got an answer of 395.61. And then delta F, what we are looking for in this particular is F1 minus F2, or F2 minus F1 for that matter. We said 240 Hertz. This is what we got on question number 10, just to update you. Then on question number 11, it was talking about a rock concert which has got a louder speak. Then beta, in this case, beta of loudspeaker, LP, is 120, it is given decibel. And then beta of the whisper, I call it WH, which is equals to 20 decibel. This is given. They ask us, what is the frequency ratio of the two? Then I also said to you, beta is given by 10 minus 10. There is a minus over there. Don't worry about it. Logarithm of I over I naught 2, the base 10. this is common logarithm base 10. And then if you put together for the first one, beta of loud speaker, which is equals to 120, must be equals to 10 logarithm of R of the loudspeaker LP divided by I naught to the base 10. Again, for the other one, what is that? 20 is equals to 10 logarithm of, let me use the other one here with a different pen which I've got access to now. Beta of WH whisperer, I'm calling this one WH, equals to 20 must be equals to 10 logarithm of I of WH by I naught to the common logarithm base 10. I said to you, remove that 10, you have 12, you have 10 here, 12 minus 2 must be equal to, I'm taking a difference of the 2. If you call this one question number 1, this is question number 2, take the difference of the 2. This becomes 12 minus 2 equals to logarithm of I of loudspeaker to the base I naught, common logarithm to base 10, minus logarithm of I of WH whisperer divided by I naught to the common logarithm of base 10. And then I said to you, I'm gonna write now very small because I don't have space. I said to you, use this logarithm law, logarithm of A to base 10 minus logarithm of B to base 10 equals to logarithm of A over B to the base 10. This rule, if you use that, this becomes a 10, must be equals to logarithm of A is I loudspeaker by I naught. I'm gonna say I loudspeaker divided by I naught over B. Instead of over, I'm gonna say I naught over log I of WH both to the base logarithm 10. Then if you continue this one, the I naught will cancel out. I naught will cancel out. You cancel that equals to logarithm of I of loudspeaker divided by I of WH to the base 10. Then what you had now is, let's see, I don't have a space. I'm gonna write here, like inside here. Then I say 12 minus 2 is 10. 10 is equals to log of I of loudspeaker divided by I of WH to the base 10. Then remember that your mathematics now, when you change from common logarithm to exponent, then this would go 10 equals to that one, your answer will end up 10 raised to 10. That's what you have done so far. Those of you in Teams who especially joined us recently, lately, are you happy up to now? Can I push you forward? Habitation, you were late. Okay, you're welcome. Go Habitation, go on. No worries about your question. Yeah, go. Let me ask you a question. Have you ever come across such scenario? If you are, for example, sitting in a car, a police car is coming from in front of you and is about to approach you. Do you know that? Let me make a sound. So it's go when it reduces. Can't you feel that? When it approaches you, the frequency, it becomes increasingly pitchy. It becomes high pitch. Once it passes you, it become lower. Yes, therefore, if you bring it into equation now, when they are approaching, the top is basically will add up, V plus VL. The bottom reduces. You're dividing big number by smaller number. I'm giving you a very, very silly explanation. But the thing is, just keep this box with you. If the source moves toward the listener, Vs is negative. The bottom one lowers. If the listener is moving toward the source, which is the scenario in question number 9, then the V of the V of becomes VL. That is a listener velocity. That VL on the top become positive. Therefore, this equation is correct. And then just continue with that one. In the second scenario, now they passed each other. When they passed each other, now the source is moving away. The listener is also moving away. That scenario is actually the away case. Therefore, this condition plus that condition. Then Vs become positive, the bottom become positive, and then the top become negative. Then you have this, the mathematics also plays very well. You have here. In the first scenario, remember the frequency we get is 636. Even though the noise from the car or the siren that is coming out is 500 hertz, it appears to UE as if it is actually 636. It increases. That means this is a pitchy sound you pick up. When it moves away from you, now the frequency reduced. Even though the frequency the system produces still is 500 hertz, what you hear in your ear now is 395, which is lower. It makes sense. Therefore, question number 10 is what is the frequency difference between when you guys means your car and the police car is approaching each other minus when it is moving apart. Habitation, are you okay there? Good. Good. Great. That is the first one. If you get the picture, put it into mathematics, and then the number must tell what is coming on. Therefore, for this particular question, you say it is B. You're welcome. And let me just have a view of what YouTubers are saying. My YouTube again is up and down. The connection at university is not good. Okay, good. Let's push. Question number 11 is basically, I think, of straightforward. Now you see I left the open area, but good. Oh, let me go back to question on the line, by the way. Number 9, number 10, number 11, we said 10 raised to 10. I'm sure this is correct. Which is correct. Good. You see number 12. Now Professor Tim removed, I hope. I know why he removed. At the beginning, the following is what is there. I'm reading for you from the olden days. It says, whenever magnetic flux linked with the coil changes, induced EMF in the circuit will change, it says, for short time, for long time, forever, as long as the flux is changing. By the way, he removed it because this question is actually, or yes, you could work through, even though it is not there. It's actually what we will learn in chapter 32, or according to your book, in second semester. I'll go into this sort of question in second semester, chapter 32, electromagnetic induction. That's why it is removed. Question number 12 and the 13 is, even though it is still to do with some sort of wave, but we will be looking through such questions in chapter 32 and 31. That's what it is removed. It's an electromagnetic induction. Don't worry about it. I'm sure you can't see from that side also. This is, I'm watching it online. Therefore, question number 12 and 13 has been removed because, it's more related in second semester than in this particular semester. Therefore, don't worry. You might not think, or you might think that, why is question number 12 and 13 removed? It's because it is better to be included in the second semester. That's why we removed. Okay, that means we will be going to chapter, not chapter, question number 14 on PHYV. Here also it's just kind of a scenario, I believe, yeah. What I have on my book also, number 14, what did I say? Yeah, there is no workout in it. It's just basically theory. It says do not follow, it could kill you. Oh, I don't know why you put it here then. I'm asking Professor Tim. This question is only about hypothetical possibility. Okay, this all is just a warning. If you were standing, it says if you were standing below an object emitting a fixed frequency of sound, falling at a terminal velocity. That's the only thing you need to know. What's the terminal velocity? As it approaches you, would you hear the sound? It says, what will be your answer? Let me include this one. The scenario is the following. There is an object which is sending a sound, like, let me call it, this is a sound wave, and then you are standing here. Then this sound is coming to you so fast that it is actually approaching you at a terminal velocity. By the way, terminal velocity, that is only some, conceptual over here, is the terminal velocity is a terminal velocity at which there is no change in frequencies. Means this is, think of a free fall, or I don't think, I've never tried, but have you ever tried jumping from plane, diving? You know what they call it, the dive. When you jump from a plane, think of like you have got a plane flying, and then you jump off. For a certain time, your parachute is not open. You move so fast that at a certain point of fall, your speed becomes constant. That constant is what you call terminal speed. That speed for a free fall, for a divers that dive from a plane, is whereby the air resistance is balancing all your movement, and then the velocity becomes constant. Not the velocity, the speed of the fall is constant. In our scenario here, that means at a terminal velocity, which is a constant speed, no change in frequency. F is constant. The question it says therefore is, if you are standing under a light, some sort of loudspeaker or some sort of sound source, and then the sound is coming towards you at a constant speed, the question says, do you think you could hear the sound? I believe what is somebody's mic is on. Habitation, do you want to come in? Please. Yeah. Yeah. Oh, okay. Yeah. The answer is even there. Yeah, you could hear the sound. Yeah. Yeah. Oh, you want to make the person to move. Mm-hmm. 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 You see now, look, your question is yes, and let me rephrase. Your question is saying, assume you're moving with a constant speed. The thing is also coming to you with a constant speed. The angle between your motion and then the sound becomes 90 degrees. What happened to the Doppler's effect in that case? I'm asking you, do you think it's going to be constant? I believe. I'm drinking water in between. You can't see me. And let's complicate a bit what you're saying. The sound is moving down at certain frequencies. This is V of the source, and then this is V of the listener, L. Then this guy produces with a frequency F naught, which is a constant frequency as a terminal speed, F naught. And then we're asking ourselves now, the frequency of this, the guy who will be the lead listener, FL, we know according to Doppler's effect is going to be F naught into, okay, let me write using my pen, F naught into V plus or minus VL over V minus plus Vs. This is what we know of. But this equation is derived if the thing is in one dimension. I'm asking you now, or I'm asking myself also, what happens if the velocity is perpendicular to one another? Yes, yes, I believe, yes, exactly. That means in our scenario, me and you created now, we're saying, the velocities are now down. Instead of down, is gonna be, this is V of the source, this one is V of the listener. Then okay, let me bring this one, by the way. It's a good question. We're killing time anyway. Let's see Doppler's effect. Hopefully, not Wikipedia. I've seen somewhere. Very good. We're talking about this one. It is derived only for one direction. I hope. Let's go there. I don't know if this thing is a good website. Come on, fast. Yeah, you see, if you go through now, I want you to concentrate there. You see, this thing is along X. What happened if we have got X and the Y component? I believe, based on, please guys, check for me. Go to this website. What happened if the X and the Y is changing? The derivation is basically to do with the wavelengths. Now, think of the wavelengths as a distance. Lx, Ly. We have now two-dimensional instead of one-dimensional. I believe, I don't know for sure. But I believe this velocity must be multiplied by the cosine or the sine, like this one. Now it has got a, this is Ly, this is gonna be Lx, the displacement, the wavelengths. Therefore, it must involve some sort of cosine or sine. I'm gonna leave you here. I believe it will be changing. I don't know. Even the derivation, or nobody has done it before. Habitation, please take as a challenge and check if this thing varies. What happened if the wavelength is going to affect, what is affected in the derivation is going to be the wavelengths. Consider wavelengths as a vector along X, along Y. Therefore, the Y component is down, the X component is to the right. We only have in this case, the listener is only along the X, remember? The observer is along X. This guy has got the sound will be affected. The Y, especially the X component, will be affected because you're going away. Please drive through, and then I will see. I will also put together mathematics, but let's not spend it now. Agree? Sure, good. But it was a good question though. What's question number 15 say? Oh, I don't know. Did okay. I don't have a workout solution for it, but I said, what did I say? It's to do with the Doppler effect again. I just wrote, it is to do with Doppler effect. I don't know what it is. Let's read. It says, if a plane is flying at a speed so that the apex half angle of its shock wave is 30 degrees, what is it is a speed if the speed of sound is 320 meters per second. I don't know what the speed of sound is given. That's all what I know of. What is apex angle to do with here? Oh, I know now. This is a kind of shock wave. Think like this. Let me just give you a scenario now. Think of you have got a plane and it has got an apex angle, like the plane is so sharp that this angle is kind of 30 degree. Then if a plane flying at a speed so that the apex half angle of the shock wave is 30 degree, okay, it is penetrating this sound or air with this 30 degree apex angle. What is the speed if the speed of the sound is this one? At what speed? What is the speed of this guy V to have such a way? I hope we're gonna use again for the Doppler's effect. In this case though, the sound toward is a stationary object and you will be something, there is air here. Let's put the air in this scenario. You will be going through air. Therefore, that air will make a kind of a shock wave. That shock wave will propagate through this whatever is that thing. The angle with which it is coming is 30 degrees. That's all we know of. Then V of the SV, the speed V, I will say is approximately is equal to V of sound. I'm taking this one like approximation, don't worry about it. Now what is the apex angle? How do we relate the apex angle with the change in frequency? I think I'm gonna go in. I'm just looking into the equation. I don't know before. I will say V of the observer. It says if a plane is flying at this speed, so that the apex half angle of the shock wave is this one. What is the speed if the speed of the sound is this much? I'm gonna say F of the observer, or FL according to that equation up, is gonna be F naught or F of the source. Let me say it S because it's a source into velocity of the sound divided by V of the sound minus or plus or minus Vs. I'm gonna start from here. This is all what I have on my screen. You might ask why you take this equation. First of all, the plane is coming. Assume the observer is standing here. Because the observer is standing, VL is 0. The top one, therefore plus or minus is 0 here. Then why you say minus now? It is approaching because the sound wave that this plane is making is approaching the observer. It is minus. Therefore, this is a starting equation. What do I have therefore? If a plane is moving at the apex angle, this is where the information is fixed at. Hopefully, I don't know if you guys go through. Do you know that this apex angle sine theta is equals to 1 over m, where this m is what we call the apex angle? Do you have this equation, or have you guys gone through this one, habitation? Okay, let's go have some sort of information about this apex angle. Okay, let me see. I don't know if people has done before. Shock wave, SHOC, shock wave. I'm just going on to, you see, just I clicked in on a Google. I see people has talked about, I don't want that, not this, calculation of apex angle of a shock wave. Oh, I don't want such a thing, man. Don't you have some? Okay, let's see here. What this wiki says? Shockwave. I'm just looking for an equation. I don't see here also. I'm just looking for if some theory. I don't want to work out. Maybe here. Nobody has done it properly though. You see, if you're looking through this, what I'm citing here, maybe this is the same equation that we're looking for. This is what I'm saying. Plugging in values, we have sine of theta is half. Okay, maybe it's the same equation people has done online. What is an apex angle of a wave, shock wave? Maybe, where? Maybe here. If you're looking through the screen, I'm going through, is where is this website? Is it? Okay, University Physics Volume 1 Shockwave. Please, this is kind of what we're looking for. It's a good way. You see this one, check here for example. This is moving. You see where the derivation is coming. That is where the derivation is coming. You are creating a wave. That wave will move forward. And then this is what we call the apex angle. You see, this is the jet. If you see habitation, what I'm indicating on my screen, that's the jet. This is the apex angle we're talking. Okay, I'm not going to go through this one. And this is what I'm actually saying. Please read about it. Habitation, have you seen? Oh, I see. Look, you know what? Olden days, I'm giving you now a bit of history behind. Olden days in 1960s or during Second World War, there was a kind of a scenario where they say they want to create a plane. Basically, this plane is a jet or a military jet. This military jet, they wanted to make for it to move higher than the speed of sound. The objective is obvious. It's for the war that they don't want you to hear the sound of the approaching plane. They wanted to produce a plane or a military plane such moves faster than the speed of sound. Then I'm talking about 1940s now, during Second World War. The science community is not developed like today. They were thinking that no, you cannot produce a plane that moves faster than the speed of sound. That was a conclusion, but it was wrong. It was wrong. Today's plane, today's MiG, for example, I don't know the proper name of the MiG, but the fighter planes actually, they are move faster than the speed of sound. This is what they call it the sonic boom, meaning you cannot hear that the plane is approaching. You only see the bomb is dropped on you. I don't want you to be there. But the objective is to strike your enemy target before they see the plane itself. If they see the approaching plane, then they can move away. The target will hide or the target will move and you cannot precisely hit it. This is what they call it a sonic boom. What it means is the speed with which the plane is moving more than the speed of sound in such a way that you cannot hear it. It is approaching. Therefore, it's actually a military way of information. Go through. It's a very good. I don't want you to be in military though. But therefore, the sign of an angle formed by a shock wave. This is what I just said. Is given by V over Vs. V is the velocity of this, the thing we're looking for. Over the speed of sound is always 1 over m. Yeah, back then actually they could not make, or they didn't, let me say, rephrase, they don't know that the people can make a plane that moves faster than the speed of sound. Today we do. The today's military planes move in principle faster than the speed of sound, and they call themselves as a sonic boom. You don't know, it's a supersonic, even faster than the speed of sound. It can hit the target. You only know it that after you are hit by the bullet, basically. Therefore, it's called the sonic boom. But go through that mathematics. The only thing that you're looking for is sine of that angle, sine 30 in this case, equals to Vs over V over Ws which is equal to 1 over m. If you rearrange this one, basically what you see is the v. I'm gonna go into my stuff here now. It's not a big calculation. That simply the velocity v that this plane must be moving at is m, which is m is now 1 over 2 twice of v of the sound. Meaning if you see this one is 2 times 320, which is equals to, what is that, 32640 meter per second. The plane therefore is actually moving 640 meter per second for such half apex angle. I know I didn't give you, that means you guys, you also didn't go through in the class. Please, I'm going to suggest to you, this is a good area to look at. It's the University Physics Volume 1. I don't know from where, which country it is, but you could see shockwave. About shockwave, it is well explained, I believe. By the end of this section, you will be able to explain mechanism behind the sonic boom. About this one, which I talked about, describes the difference between sonic boom and the shockwave. You see, whenever a plane is moving inside the an air, it creates a shock wave, and then the shock wave have to move with a certain speed also. Therefore, we describe this one with a bow make, or it says describe a bow wake. Bow wake is basically, if you read through, you will be awakened when you are hit by something. But I like the mathematics is down there. It's, even though it's a bit of approximation, you see this one. Vt is velocity times time. Vs times t is also velocity to sound times time. That v is the velocity with which the plane is moving. T is the time it takes from where it is to where it's going to approach. You guys go through. I like this thing is basically a very good applicable area in the military. Leave. I'm going to leave for you. Therefore, what did we say here? Question number. Thank you guys for the climbing. Thank you. Where are we? And the 640. I will say, check. This should be okay. Yeah, it's a 2 eyes basically what I will see. Thank you for the YouTubers also. Let me check what my tubers are saying. Yeah, good YouTubers. Thank you for the like. Go through. Good. Let's go question number 16. Where am I? Yeah, question number 16. And what is this one talk about? What did I say on my paper? Just to have idea. Okay, so just basic equation. I think it's a simple. It said, it is possible to hear an approaching train before you can see it by listening to the sound wave through the track. This is true. Yeah. By the way, do you know that elephant hear by their feet? Because sound propagates faster in a solid medium than the air. Meaning if you make a sound from far away, elephant actually hear very quickly because they are using their feet. They listen, they call it. They listen by their foot. But yeah, because just basically if you are, for example, on South Campus now, if there is a plane, or not a plane, a train arriving at the North India, for example, if I want to hear the train coming, it is better to put my ear onto the train track. If you put your ear down there, it propagates through the metal very fast than the air. Therefore, it says it is possible to hear an approaching train before you can see it by listening to the sound wave through the track. Because track is solid, air is a little bit not dense, therefore track brings the information quickly. Good, let's continue. If the elastic medium of this thing is given, the elastic medium of the track is given 2.0 times 10 raised to 11 Newton per meter square, and the density of the steel from which the track is made is 7.8 times 10 raised to kilogram per meter cube. It's a volume, it's a density obvious, mass over volume. Approximately how many times faster is the speed of sound in the track than in air? You see how fast basically. But I just put my on my equation. I'm gonna bring my tablet also in. This is the next question. I put my equation saying, I said V in a solid. V is given by the equation of, that's all what I have on my paper. Beta, the modulus, Young's modulus divided by the density rho. Therefore, if you use this one, the velocity would be equal to the square root of beta is given, yeah, it's the youngest modulus is given, 2 times 10 raised to 11 divided by 7.8 times 10 raised to 3. It should be in meter per second, obviously. And then what did I get? What else I could get? What do I get out of that? Therefore, what do you get out of this one? I don't. Yeah? Okay, I believe so. I'm not gonna work. I didn't write anything from there. This expression is, you said 50, 63? Is that what I have? Let's say 0.7 divided by, oh, okay. This is meter per second, not divided by meter per second. Therefore, the question is, what is the ratio? V of the sound is here. Therefore, the ratio must be like, should I say ratio, okay? We're looking for is 50, 63.7 divided by whatever they gave us, 340. What do you get it then? Habitation, are you doing for me? What is this ratio? Hey, thank you. You can see what I'm writing, 5063.7. Let's say 14.89, thank you. Let's say it's about 15 then. If that is the case, the 15 is there. Let me go on to the website. Should be easy then, 15. Yep, it's right. Thank you, Habitation. You see, I like you and thank you for coming on always. And you help me in calculating. Good. That's all right. That is a very easy question, actually. Number 16. Number 17, if you push it in, says the fundamental frequency of the above middle C on a piano is 440 Hertz. What is it talking? Let me go onto my tablet so that I could see through. Let me make like this, a bit tougher, yeah. The fundamental frequency of above middle C on the piano is 440, okay? That is F naught is 440 Hertz. This is tone high A. I wish I know music. This is about a piano. Now that means if you're playing a piano, you must know A, B, C, D, and bing, 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 some sort of sound they produce. This is the tone higher A, but the convenient note in the middle range of woman's voice. Oh, okay, somewhere is the frequency is within the woman's voice. For example, my voice is ugly. It's I don't like it. But the humans might go. It's a middle voice. It says what we calculate the wavelengths. When we calculate the wavelengths, we find that this thing is kind of, it need a knowledge of a piano basically. What I put on my note. Oh, I've got an equation there. It says, do I have another page? I put an equation that the frequency F of such for a piano, I believe, is F naught into, I don't know where I got this equation, into the 12th root of 2, let me make it shorter, 12th root, I'm gonna rewrite this thing, man, I don't like it. She is not correct. Open, yeah, 12th root of 2 raised to, I say, n minus 49. I'm sure you guys, you don't know this expression either. Therefore, where do I get? Fundamental frequency of a piano. There is I believe there should be some sort of website. I'm just gonna put this one down. You see, music 101, it says. I believe I'll get it. Do I have this equation somewhere? I'm not gonna spend my time on music 101. I want some sort of nice, maybe here, fundamental harmonic frequency, background. I'm looking for that equation. I just put it on. Where do I get it? Don't like these people. They say pay. Maybe piano cave. You say sorry, attention. I didn't hear you. Yeah, I know what you mean. I'm gonna go back and you saying make this one image and then you could easily pick it up. But I believe I got it now. You see, piano frequency is Wikipedia actually. I don't know where I picked it up. You see, this is a sort of frequency I'm talking. F in n equals to 12 is root of 2 raised to n minus 9. They did a calculation for us even. Oh, I don't know. This exists. The following equation gives the frequency f hertz of the nth key on the idealized standard piano with the 49 key with key twinned from to A4 at this frequency. It looks like exactly what we have. Therefore, what I say is solve for n equals to, what is our n gonna be? Let's go back to the question. The fundamental frequency of the above middle C on the piano, we are looking for that one. What is the n for C? On the piano is this much. The frequency F naught is known. That means you know this F naught, which is 450. What is n? I don't know. Okay, how do I know my n there? Or, yeah, what is n gonna be? 2 raised to the where n is shown in the table below. Oh, okay. How can I make it big? Sure, this is too small. Middle and C. Can you find for me where is okay? Somebody raising hand? Subulele? Are you fine? Okay, I'm looking for n actually, middle C. I'm just jumping up and down. What is the middle C? What is the n for that corresponds here? What did I write on my n? What is n gonna be? This is in the toner high A. That's where the toner high A. But guys, go for it. If it is middle, I will believe it should be around 40. 40. N gonna be, where is n 40 here? It's down here, down here, down here. Yeah, here. You see? The question is just basically understanding piano. Middle C, habitation, you follow if you don't understand. Middle C is n is 40. You see there? I'm bringing my cursor. N is 40. Therefore, if you put n equals to 40, you will find that that frequency would be equals to, I just put the number there, 261.6 hertz. That is what you get. Then now, lambda, the wavelength is lambda, would be equals to V over F. V is 340. We're using that of speed of sound. 340 divided by the frequency we get is 261. I got the wavelength of close to 1.3 meter. That is the sound. Then now we go back to the question. You see, the wavelengths, we got it. It says, when you calculate the wavelengths, we find that much shorter than the length of either man's or woman's lip. This is wrong. because it's too long. Shorter than the length of a man's lip. Ah, come on, man. I'm not going to compare with the lip here. Longer than a human's lip, but forget about this one also. Much longer than the length of either a man or a woman's lip. I'm going to cancel everything. About the same length as either a man or a woman's lip. What is going to be the answer? Or if it is comparing with the lip, you know what I'm going to say? We get 1.3. Let me see. 1.3 is much longer. Which one is the best answer? Shorter? No. Shorter? No. Longer than woman's lip is longer than everybody. Much longer than the length of either man's lip or woman's lip. I believe D should be the correct answer. If you disagree with me, let's go check. Habitation, are you happy if I say, because we got that is too long, 1.3 nanometer. What is that? Meter? I'm going to check D. Okay? I don't know. Professor Tim also agree with me. He's copying. Yeah? Habitation? I agree with you. Again, this is, what do I need to know about the frequency of that is such a thing? I agree. Are you saying this question is supposed to be erased? Exactly. I agree with you. This is not supposed to be here. But you know, it actually took us through so many of things. Yeah, you see. Maybe I will say to you, yes, we know the frequency of, at least we learn the frequency of a piano. That is the only advantage I learned from here. But the derivation, I don't expect you to go into driving Fn is equal to the 12th root of da da da. I don't know either. I didn't go through. I just copied that equation. I agree. It's not the equation that's supposed to be for engineer. Agree. Let's even not spend time on it. Happy? I forgot about my YouTubers though. Okay, good. My YouTubers also, thank you for liking. They are still happy with what we're doing here. Question number 18. Where am I now? The variation in the pressure of helium gas measured from equilibrium value is given by delta P. I'm going to go to my tablet. Next slide. I've got empty space there. Okay. Delta P. Red. Delta P equals to 2.9 times 10 raised to minus 5. It's a cosine function. I'm not going to write like that. Delta P is equals to, let's say, P naught cosine of kx minus omega t. I better write in this way. It's a sinusoidal cosine in this case. You might say cosinoidal, but we all call this one sine, a wave, sinusoidal. Then for such sort of wave, we always write kx, that is a displacement relative to k is a wave number. I hope you guys know this one. Wave number, k is wave number, omega t is a frequency related, but it's a phase change, phase angle, omega t. Then this is what we know of in this expression. P naught is 2.9 times 10 raised to minus 5. And then K must be the expression 6.2. Then omega must be 3000 because it's an omega t. I think the question is basically to ask, do you know that you can write in this one? And then what is K and what is omega, isn't it? What else it says? Where X and T have units of M and S, and the delta P is measured in Newton per meter square, obvious. This is a Pascal or whatever SI unit of a pressure. Determine the frequency in hertz of the wave. Easy. Remember, omega is 2 pi f, I believe. Yeah, is it not what we're going for? This implies that the f should be equal to omega by 2 pi, where the omega we know of is 3000, according to my expression. 3000 divided by 2 pi. Therefore, what do I get? This one by 2 is this one 15. 15 by 2 by 2, 1500 divided by 3.14. If I say this 3, is this about, let's say 3? about 5 something. What do you get? It's just close to 500. Which one is the closest? 4.77. Good. Let's say therefore about 500. You said 477.7 hertz. Do we have it here? Oh yeah, it's there. It's there. 477. Yeah, good. But I would be happy if they would have said that 478 because we are rounding up this one, and then this is 478. If your calculation is okay, let's go back into the software and check what they say. Maybe that is the closest we could get. Yeah, it's correct. This is how far I wished to move today, but yeah, if tomorrow, I think Arnold will take from question number 19. Are you guys happy up to now? Yeah, habitation. I don't know. They don't CC me either. I agree what you're saying. Do you guys have a reminder, kind of a YouTube, not YouTube, the Teams or YouTube reminder that we are going live? I don't know if these other tutors send. You saying habitation, they are not sending. They don't CC me, obviously. I don't know. Oh, I see. I see. Wait, I will also update our group so that they will send at least in the morning. Today, I also late to send around 11 because I was busy with other one. The intention is if we send early in the morning so that you guys you put. Now what I'm learning from you is you don't get like an email in the morning in such a way that you plan for it. Thank you. I'll remind our troops, I call them troops because we will be working as a group. Thank you, invitation. I'll update them. But tomorrow, and then tomorrow is Thursday, and then Friday, in principle, they will be live from 12 to half past 2 or 2 around there. I will ask them so that they will send an email in the morning, but just for your information, they will be live tomorrow as well as on Friday just to finish. Next week also we will be live Wednesday, Thursday and Friday so that we will finalize. You guys, if you are interested in, we could also come during the PHYV class, onto the class itself when you guys finish, when you are ready for the exam, especially because you will be writing your exam from unit 1 all the way to the last unit that you have covered. If you have a question, if you have a tutorial that you wanted to ask a question, we could come also on into the class, then we could talk in person. But yeah, I will send this reminder about the email, but I will update you also to by email that if anybody want physically either to come see us or to go to the class, the real class during PHYV class, we will be happy to come and spend the time with you for the exam especially. Habitation, I lost you in between. I lost you in between. Say, use. Habitation, there was a breakup in between. I could hear you now. Go back. You said you have got a question. Mm, 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 mm. That is exactly correct. That we will be happy to assist you. Group of 8, that's great. Even we could either you guys you could come to the south campus or we could come to the north campus if you mostly you spend there. But coming to north campus will be difficult because we need a kind of a little room per se to discuss. But if you guys have such sort of question, send me an email or send us an email to a group of us. Send me an email, for example, just mainly because I will be the one representing the time, not the time, but the kind of leading the group. I will organize for you in such a way you can come here or we could find a place so that we'll sit together and solve. That is will be a very good equation if you manage to have such a thing. Don't hesitate to ask us. No problem for that. Yeah, let's stop here and for today I will be expecting you not only now or do it not only on Wednesday, Thursday, Friday. It could be Monday. If you have a question like in a group, as you're saying, in a group of 8 is not small. It's substantial student. Why not 10? If why not 3 even? If you manage 10 of them, no worry. We have laboratories around. We have got rooms around also. Extra classes are here in the lab. We will accommodate you. Don't hesitate. Before the what is that? Obviously, don't wait though until the exam time approach. It is better to work through from now until the exam time. You could have 2, 3 kind